Um, all right. Oh, that's better. They have changed out my microphone because I understood, or the staff understood, that people online were having trouble hearing me. So we'll try this. Let me know if it's working any better. Okay. So at this point, we'll move to that part of the agenda where we hear from those of us designated as initial discussants of the evidence. So we'll begin with the human evidence and hear first from Dr. Crespi and Dr. Stern on cancer studies in humans, then Jason Bush and Tom McDonald on the animal cancer studies, and after that, Dr. Felsher and I will talk about pharmacokinetics and metabolism, and finally, Dr. Alexandrov and Dr. Wang on the key carcinogenics of key characteristics of carcinogens. So, Dr. Crespi, I think you're up first as initial discussant on cancer studies in humans.
Thank you. Um, yeah, so, well, the staff this morning had a very good summary of of the highlights of the epidemiological studies. So I don't want to repeat everything that they went over today. Um, I don't think they talked much about the occupational exposure studies, but there wasn't really much there. They were very limited. Um, so the study I think that is most relevant for our deliberations is the HEC study of ambient air toxic exposure in breast cancer, which I think has a number of strengths, notable strengths, including the study population. It was a large population-based prospective cohort study, the multi-ethnic cohort study. It's very well studied cohort um, with unlikely to have a lot of selection bias associated with it. There, um, sorry, I was going to pull up my notes, so I'm a little behind on my notes. Pull up my notes. I think a few things to add, some things that popped to my mind about this study as we were having some discussions this morning. Some relevant facts about this study is that they enrolled individuals when their ages 45 to 75. So most of the women who were enrolled were postmenopausal or close to menopause, um, which makes it particularly well suited for studying postmenopausal breast cancer, which was their outcome, which they assessed. Uh, Another strength of the study was the inclusion of the multiple ethnicities, and they had a diversity of socioeconomic status within the cohort. So I think their study population was very well suited for the study. Um, they also had very robust collection of potential confounders and risk factors, lifestyle factors, et cetera, that they collected by questionnaire. So it's self-report, but a very good, robust collection of confounders that they adjusted for in their analyses. So that's definitely a strength. And also their residential histories, having that available is also a great strength of the study. So the exposure assessment, I think there were some uh, concerns or issues raised this morning about how exposure was assessed at perhaps one, or I think it was 2 points in time, like three years apart, essentially, in the air toxics modeling, and that it wasn't the exposure assessment wasn't assessing exposures that were farther back in the life history of these individuals. But I think that it's epidemiological studies. You have to take the data that's available, and these data just aren't available going back into the early life of these individuals. So, but I think we can take their exposure assessments as a marker or an indicator of exposure rather than, holding it to some high standard that we don't trust the study unless they have exposure histories going far back. We just don't have the luxury of that very often in epidemiological studies. Let's see, some other points I wanted to make are that the vinyl acetate, I think it was mentioned, it wasn't highly correlated with any of the other studied chemicals. So we can't really associate those high hazard ratios with correlation with other chemicals that were studied. So I think that, my assessment of that study is that it was a well-conducted study with a lot of strengths. There's some information that's missing that I wish was there. So it's not perfectly reported. Some other things that I wish they had done. Like I don't understand their increment that they use to calculate the hazard ratio. It's not that clear to me. But that hazard ratio is very high. And it's high and across all of their stratified analyses and all their sensitivity analyses. And it's hard to think of some source of bias or confounding that would create a hazard ratio that high in this kind of a study. So I guess that I find this study is very informative to us in making our decision here today. So that's my comments.
Okay, thank you, Dr. Crespi. Dr. Stern, anything to add?
Yeah, I share the same comments as Dr. Crespi, and I agree that the study from the multi-ethnic cohort is very well designed and done. And, aside from doing an interventional study, which would be the gold standard, but would be unethical, I think doing a prospective study like this one, a cohort study, is really the gold standard in epidemiology. And I think I share the same view as Dr. Crespi, that I think of the exposure here as an indicator of what the exposure that they had likely before, and the analysis they did, considering people that may have moved over their lifetime, I thought was very well thought out and kind of shows that the findings remain the same. So I thought they did a very good job of considering all possible confounders. And the other comment I want to make about this study is that the limitation that they did not assess exposures earlier in life, or that there could be some residual confounding due to other unmeasured factors, would be non-differential, meaning that it would affect everybody in the cohort. So it means that when you are comparing the cases to the controls, likely it is biasing the results towards the null. So it may actually tell us that the real estimate of association may even be higher than what we're seeing. So that's an important point to keep in mind when we think about these kind of biases. The other thing I want to mention is that they did a pretty thorough job of looking at, they consider over 180 potential agents that they could measure. And they did a careful job of selecting those that they thought could have a biological mechanism by which they could lead to breast cancer, and also that they were prevalent in the LA basin. And that's how they ended up with those 15. So, and they did, as the team shared before, the OIHA team shared before, they look at correlations between these agents, and there really isn't a strong correlation between vinyl acetate and the other 14 compounds that they looked at. For the other compounds they didn't look at them because they were not really prevalent in the area. So I think that is telling us that it is unlikely that what we're seeing is led by another compound that is commonly present in the LA basin, since they pretty much consider, a lot of other compounds that were not including the final analysis. So I agree that this study is very well done, and it gives us very useful data. I also wanted to make a very quick mention to some of the studies from the occupational studies that were not really discussed. And, they were all very small. The assessment was through occupational records, so there's some issues with that. But I wanted to mention one study that caught my attention, which are the studies that were done on brain tumors. Because these studies were done by NIOSH because there was a report of a cluster of brain tumors among workers of one particular factory. So NIOSH did this study, and it was very small. They didn't really present estimates, but they did find some evidence that there was higher levels of exposure among those who had cancer compared to those who did not. And then the company, Union Carbide Corporation, they published an independent study reanalyzing the data from the cohort, and they confirmed that for vinyl acetate, there was an excess of exposure among the cases. And they also did an independent case control study where they found that 60% of the cases were exposed to vinyl acetate compared to 47% of control. So it's about a twofold increase. They didn't present the estimates, but the OIHA team calculated them. So numbers are super small, and the assessment, there are some limitations with the way that the assessment was done. But again, any issues with the assessment would be non-differential. They would affect everybody in that factory, not just the people who develop the brain tumors. So again, they probably are biasing the results towards the null. So I thought it was worth mentioning that study because it was repeated by different teams, including the same company where these workers had been diagnosed. And they confirmed that there seemed to be an excess of exposure among those with brain cancer. So I wanted to highlight that. There was also another study done also with occupational exposures that showed a positive association with non-Hodgkin's lymphoma. Similar limitations, occupational exposure measures through work records and small numbers, but I think it was worth mentioning that. So I'll stop here.
Very good, thank you. This was, for the benefit of the new members, a really good illustration of how we like to do the discussion here. With the initial discussion, we ask that they not read from detailed notes verbatim, but give a quick summary of their overall views of the evidence, with the second discussant adding to that anything omitted or other interpretations of the evidence. So with that, let's move on to studies of animals, and Jason Bush.
Thank you, Dr. Loomis. Firstly, I'll start with comment and credit to Dr. Sandy and Son. I want to congratulate you on the quality of the HID. Having reviewed these things now for over 10 years, this was particularly sophisticated, so I very much appreciate that. So kudos to your team for the effort, continued dedicated due diligence that you perform in putting these things together. Secondly, I have read the public comments from that were submitted, notably the Vinyl Acetate Council. They have several compelling counter arguments that do have merit. So I am considering those in my determination. Now let's dig into it. So going to remind you, we're dealing with 24 animal studies, so 6 rat and 8 mice. And I'm going to take a more macro view. I think the OHIA team did a good job digging into the data. I'm going to really paraphrase in terms of my determination. So based on the information provided in the animal studies, vinyl acetate demonstrates a pattern of carcinogenicity across multiple animal studies. And I'm coming to that based on 6 points. Could be more, but I'll be quick, okay? First, statistically significant tumor induction. Vinyl acetate exposure was associated with significantly statistically significant increases in various tumor types, including rare and malignant tumors across multiple species, strains, sexes, and exposure methods. These include the squamous cell carcinomas, adenomas, adenocarcinomas in diverse tissues. Secondly, dose-response relationship. Many studies identified significant dose-related trends in tumor incidences, strengthening the causal link between vinyl acetate exposure and carcinogenic outcomes. There's consistency across studies. Tumor formation was observed in multiple animal models, rats and mice, under both inhalation and the oral exposure conditions. This consistency enhances the reliability of the findings, in my opinion. And the relevance of rare tumors. The induction of rare tumors, like the squamous cell carcinomas of the forestomach, oral cavity, and esophagus, is a notable indication of some carcinogenic potential. I appreciated the table related to the different plasias that you were seeing in the data. And I think that adds a level of credibility. We know that metaplasia, dysplasias, hyperplasias are fairly good surrogates for the carcinogenic potential. And so highlighting those, I think, is a particularly important aspect of the HID. And then, of course, the issue that we've talked about, the acetaldehyde connection with vinyl acetate. Yes, it's a complicated metabolism. Yes, there are other things that contribute to endogenous levels of acetaldehyde. Diet can be one of them. But that connection, I think, is very strong evidence of why vinyl acetate ought to be considered as a carcinogen. And so, in conclusion, weight of evidence from these studies supports classifying vinyl acetate as a carcinogen, in my opinion, due to its consistent tumorigenic effects across multiple animal models and exposure scenarios. With that, I'll yield my time.
Thanks, Dr. Bush. Dr. McDonald, it's over to you now.
Oh, thank you very much. Can you hear me fine, or should I bring this closer? Okay. Once again, thanks to the AWEHA staff for pulling together such a large amount of information on vinyl acetate carcinogenicity. It always is an immense amount of information that you compile, and I concur this was a very well-written report. Thank you. I'd also like to thank the public comments. They were also very informative and provided some points that were not covered in the HID, so I appreciated that. I'm going to structure my remarks in the following way. I want to first discuss the authoritative body with respect to the animal calls, and then I'll go into the studies themselves. Just, I don't want to rehash, but try to just highlight again the consistency there. And then I also want to spend some time discussing the limitations and criticisms of the animal studies, which reduce the impact somewhat, and I think the committee should all discuss that as well. So let's start with IARC. We heard earlier today that it's limited evidence, but that was based on its transformation to the putative metabolite acetaldehyde, and they both acetaldehyde and vinyl acetate cause nasal tumors. IARC covered 8 bioassays, but as you saw in the HID, we have 24. I think also the HID stated that EPA hasn't looked at it, NIOSH and NTP haven't formally looked it up, and FDA as well. I did see in the Vinyl Acetate Council comments that FDA does permit the esterification of starch by vinyl acetate. And so I assume that that's a reaction and there's some monomer left, so that's not a formal hazard ID. although not an official Prop 65 authoritative body, the European Chemical Agency looked at this formally in 2011. And I think it's worth noting that that authoritative body stated that vinyl acetate was carcinogenic in 2 animal species and in both sexes. It also demonstrated, in their opinion, inhalation and oral carcinogenicity. So I think that's worth noting here. So let's first take a look at the cancers, the bioassays. I won't go into the detail, but I'd like to just try to focus on consistency and then criticism. I saw little evidence throughout that the maximum tolerated dose was exceeded. This conclusion is also consistent with a European Joint Research Center. They did a formal analysis and suggested that the MTDs were not exceeded in these animal studies. There is high nonlinearity in the data. The high dose group is often the only one that showed tumors. And this may relate to the mechanism of action, which we can talk about, I'm sure we'll talk about later. So I want to just briefly, tick off some of the findings in the studies. I don't want to rehash what's been already presented, but I just wanted to talk about the consistency. In the inhalation studies in rats and mice, we saw nasal tumors in the male rats and suggestive evidence by statistical trend in the female rats, but there was negative studies in the mice, but there was also pre-neoplastic proliferation lesions in those studies, but no tumors. In the oral studies looking at juvenile dosing through adulthood in rats, there was the study of Lajinsky and Ruber, and the males were not, there were no tumors there, but in the females, even though the tumors were rare, these were endocrine carcinomas, they were rare and statistically significant by trend. But what's interesting is when you look at the author's discussion of those, they were very large and invasive and metastasized throughout the peritoneum. So this is a very unusual finding. Also, the studies from the Japanese Bioassay Research Center showed the oral squamous cell carcinomas. Minardi, you saw the forestomach carcinomas. And then you had the oral studies where they started early life and then all the way through adult dosing. The studies by Bogdanfy et al. In rats were negative, but there were 2 squamous cell carcinomas of the oral cavity. And then the studies by Minardi and Bellapoggi, these are the Ramazzini Institute studies, were all positive, showing statistically significant tumors by pairwise and trend tests of the oral and lip, tongue, forestomach, consistent all the way through. And then in the Bellapoggi females, a uterine adenocarcinoma. So consistency is what we're seeing here. And then when we move to the oral studies in mice, starting at juvenile all the way through adult dosing, we see the same sort of thing: oral cavity, esophagus, forestomach, those point of contact tumors being quite substantial. And then in the Maltoni Swiss mice, we see the same sort of thing in males and females: the oral cavity, the tongue, esophagus, forestomach, all those point of contact sites. I did want to spend a couple minutes talking about the criticisms of the studies. That all sounds very, powerful and consistent. There were some discussions about the lifetime dosing and watching the animals to a natural death. Several studies, specifically the Ramazzini Institute studies, did that, where they have a protocol. That protocol has been has been criticized by some because it can lead to high background incidences of spontaneous tumors. However, for these studies of vinyl acetate, the tumor incidences and the controls were at or near zero. So that really doesn't follow as a valid criticism for these studies. And that we also, excuse me, talked about the fact that the Ramazzini Institute studies were suspect. This would relate to the Maltoni study, the Minardi study, the Belpogi study. As noted, the EPA IRIS program has stopped using those studies for its analysis, and the NTP is gone through an audit back in 2011. And I read that audit report, and it is around methanol, MTBE, ETB, and vinyl chloride, so it's about the same era, but they're different chemistries. But I was struck by the fact that NTP was worried about that both of the studies, there were chronic inflammation in the nasal cavity, ear canal and trachea and lung, indicating an infection of one or more respiratory pathogens. Chronic airway inflammation due to Mycoplasma pulmonis and perhaps other pathogens may have led to differences in opinion in the responses. Malignant lymphoma, which was mentioned, but also squamous cell carcinoma and osteosarcoma. So anyway, it's interesting also that the European Union, when they analyzed acetaldehyde, there was a study by Safridi in 2002, the same era as these studies. And the European Food Safety Administration took that study off the table for its analysis because they were worried about this background infection rate. So how should we view this criticism? For me, background inflammation can clearly drive the tumor responses that we're seeing. But, I don't agree that with the EU that we should completely eliminate these from the analysis. The way I look at these is the target tumors and the tumor types of the Italian studies, the oral cancer studies, are reasonably consistent with those from the Japan and even the US studies. So even if we put them as a supportive evidence, I think the Ramazzini studies all point in the same direction as the other studies. So I'm still on board with that. Then the final criticism is around the instability of the dosing solutions. I don't think that's discussed here. All of the studies started with solutions that were of high purity, but all of them were unstable. Specifically, the Lajinsky and Ruber, for example, lost 8.5% from volatilization by every day, and the solutions were only made twice weekly. And the Umeda and the JBRC study, the Japanese study, produced twice weekly dose solutions, and they estimate somewhere between 70 and 80% of the vinyl acetate was lost to volatilization. So, and then the Bogdanfi studies, in comparison, made their solutions daily, so they have less of a concern, but everybody is test article as they go along. I mean, for me, it creates some concern that you don't know the exact dose, but and this tends to just lower the overall dose to the animals and makes it less likely to see a toxic effect. But admittedly, we still saw statistically significant induction of malignant tumors even with the lower doses. So my bottom line is that given the concern over the studies, I think the overall picture is less strong than we take a first look. However, the totality of data, the positive tumor findings seen in 2 species, even though the studies have some concerns, there's overall consistency that support a weight of evidence. And I think we shouldn't forget that the tumors from acetaldehyde overlap, the same tumor types, and tumor locations overlap with vinyl acetate. So I would conclude that vinyl acetate is clearly shown to be an animal carcinogen, but I'll keep my mind open to hear public comments and committee discussion for a final decision.
Great. Thanks to both of you. We'll move on now to pharmacokinetics and metabolism. Dr. Felsher, you're up first on the agenda, so you give us your summary of the evidence as you see it.
Thank you. Oh, shoot. It just freeze for you guys. Okay. Sorry, I froze for a second. Thank you for the chance to talk. I think the issues of the pharmacokinetics and metabolism were very nicely and thoughtfully organized as presented to us earlier today. There are basically 4 kinds of issues, I think, that are worthy for our consideration. It's important to consider the fact that we have an idea of how this putative chemical carcinogen is bioactivated and how it's metabolized and eliminated. Certainly, there are considerations in terms of how it gets distributed through the body and considerations about whether or not it actually reaches target organs of consideration of carcinogenesis. Has it been described already? It's clear that this is a chemical that we have a pretty significant understanding of how it gets distributed in the body. There's excellent studies in animals in particular that have explored its ability to be absorbed through multiple routes, including inhalation and gastrointestinal and through skin in some circumstances exposure. And then it had already been described. We also have a good idea in cases where in animal studies, in particular radioactive, vinyl acetate has been used, that an idea of where it actually physically gets distributed into animals and the kinetics at which it gets distributed. And those all really support that the chemical, when consumed or exposed through different routes, is widely distributed through the body and is distributed to organs in which there's evidence for carcinogenesis has been already summarized. In particular, we've already heard a discussion of how vinyl acetate gets bioactivated. And in particular, it's a chemical that gets metabolized to acetaldehyde, that this is very important because, of course, as we've just already been discussing, acetaldehyde, there's already significant evidence of its carcinogenic properties. And we know that acetaldehyde is also further metabolized by the LDH2 gene, and we've discussed already and heard how that's a very important way in which this chemical is inactivated and provides more understanding in terms of the mechanism and ultimately how it's eliminated to acetic acid and carbon dioxide and released from the body. One thing that perhaps hasn't been talked about in terms of aspects of how the chemical can be bioactivated and contained within the body in a dangerous way is that radioactive studies of vinyl acetate have also been used to actually explore whether or not when it is bioactivated to acetaldehyde, it actually does form adducts with other chemical compartments. Most notably, does it form stable binding components with DNA? And there is evidence that that occurs in these same studies that have explored the pharmacokinetics and metabolism. So I think on balance, the study suggests that we have a good understanding of how this chemical can get taken into the humans or animals and how it gets biodistributed and how it gets activated and how it gets eliminated to provide us a framework for considering whether or not the carcinogenesis that's been observed in animal studies and has been associated in epidemiologic studies. Is it consistent with what we understand about this chemical? One thing that we haven't discussed that may come up in the discussion is that most of our understanding of the carcinogenesis of this chemical is in its form of acetaldehyde. But it isn't that there aren't studies suggesting that vinyl acetate itself may, in some circumstances, have some dangerous qualities. And that's perhaps something that is worthy of discussion. So those are the comments that I was prepared to provide to you. Thank you.
Very good. Thank you. Well, I'll add a bit to that. So having heard from previous discussants that there is evidence of carcinogenicity in experimental animals, and knowing that the human epidemiological evidence is sparse at best in terms of numbers of studies available anyway, I think that what you make of the metabolism of vinyl acetate to acetaldehyde is kind of a key piece of causal inference with respect to this listing. And with that in mind, it may be helpful to think a bit about previous authoritative body evaluations of acetaldehyde and vinyl acetate. We don't necessarily have to follow those in this instance, but it is interesting to note that when vinyl acetate was evaluated by IARC in 1995, at that time there was limited evidence of carcinogenicity in animals, inadequate evidence in humans, and yet the working group made an inference based on studies of acetaldehyde in animals that because there's sufficient evidence of carcinogenicity of acetaldehyde in animals at that time, and this was in 1987, I think, they upgraded the evaluation from what would have been group 3 to 2B. So since that time, acetaldehyde was evaluated again, also classified in group 2B based on sufficient evidence in animals and inadequate evidence in humans. And then the next evaluation of acetaldehyde was really interesting because it was done in conjunction with evaluating the carcinogenicity of alcoholic beverage consumption. And so in that case, again, the IARC working group inferred that because individuals with the ALDH2 star2 allele produce more acetaldehyde and have higher incidence of cancer, that acetaldehyde in conjunction with alcoholic beverage consumption is carcinogenic to humans. So that is a really important inference, but I want to point out that it is an inference and there isn't direct evidence in humans of a link between production of acetaldehyde and development of cancer. And so I think you could look at this two ways. You could say, well, I'd really like to see that direct evidence. Or you could think, well, this is the way science works, isn't it? That we have this piece of evidence, and another piece of evidence, and we can make a link between those. And I think that link is there, and that the evaluations that IARC working groups have made over the years are kind of a guide to how you could proceed through that inference. I think they were done according to IARC's protocols. Again, we don't have to follow those, but it is informative to know what they did. One other thing I would add is that I think it's important for this committee to consider the evidence on susceptible groups. And as we heard in the very helpful presentation by the staff, there are at least 1 million Californians who may have heightened susceptibility to the potential carcinogenic effects of vinyl acetate because they possess that ALDH2 star2 allele that inactivates or partially inactivates the metabolism of acetaldehyde. Well, that's a way to focus attention. I think we'll wait for this to stop before we move on. Okay, that may be it. Um, let's go on to key characteristics of carcinogens. Dr. Alexandrov, you're up first on the agenda.
Thank you so much. And again, I want to thank the WIHA staff for the very well written report and the presentation. So I will wait.
Sure.
So when it comes to the key carcinogens, there were 4 key carcinogens that were presented, where there is some evidence. I have to say, from my perspective, it was very refreshing to hear all the other committee members talking about the different evidence on the different considerations. So when it comes to the key characteristic of carcinogens, just to remind you, the fact that something has a characteristic of carcinogen does not mean it's a carcinogen. When it comes to the key carcinogen 1, it's electrophilic or can be metabolically activated. When I was looking at the evidence, there were multiple papers that were supporting that. I felt that this was quite compelling. I think it was quite clear. But when we come to the key characteristic of carcinogen 2, the genotoxicity, I personally felt that the evidence there was a bit weaker. When it comes to chromosomal effects in humans, that was relying on one study from the Soviet Union in Armenia, which was quite old. I have a number of concerns about the sample size was small, even though they took 100 cells per patient. And again, it didn't seem particularly well conceived. And also it was hard to judge some of the corrections, if any, that were done, whether the individuals were age match, sex match, tobacco smoke match, etc. In contrast, when it comes to the micronuclei formation in the sister chromatid results, there were multiple studies that both in vitro and in vivo, and I personally found them very convincing. From my perspective, it was very clear that we can see genotoxic effects in experimental systems. The DNA damage was a bit of a mixed bag. There were studies that were showing that there is no DNA damage effect. There was crosslinks, but not specific crosslinks being mentioned. I think it's very clear that there is adduct formation, but whether this adduct formation leads to somatic mutagenesis and whether that somatic mutagenesis is relevant to carcinogenesis, that wasn't particularly clear. And the last part of the genotoxicity is the mutations. And again, I found there that the studies, even though the most recent studies was from 2013, I believe, it's about 10 years old, they were using reporter genes. There wasn't that particularly strong evidence. That wouldn't be the way one would conduct this study today if one conducts it. So when it comes to somatic mutagenesis, I didn't find that there was sufficient evidence there. When it comes to the key characteristic of carcinogen, the 10th one, outer proliferation, cell death, or nutrient supply, I thought that this was crystal clear, at least from my perspective. There is very clearly cell proliferation. The multiple in vivo studies show hyperplasia, they showed dysplasia. I thought that there is absolutely no concern there, that's a very, very clear cut result to me. What I worry and what I'll express in the discussion session is that being able to create this dysplasia and hyperplasia may be confounding some of the mouse results that exist. And that has been my main concern as part of the mouse studies, but we can discuss that later. This is the summary of my remarks. Thank you.
Thanks, Dr. Wong.
Thank you for that summary. That was great. And I largely agree with those comments. I'll just add a few things, so my comments will be brief. I agree that for there were 3 that were considered key characteristics, and the characteristic 1, that it is electrophilic and particularly that it's metabolically activated is, I think that has been clearly stated based on the studies. And I found what was particularly compelling is that these addicts are often identified in the route of exposure, so in the nasal, respiratory, and olfactory epithelial. I want to point out that for KC2, I actually found the data sound. I do want to remind the panel that genotoxicity was already supported by the IARC report in 1995. But I do agree that there was new data that was presented that were published in 2013, and those data were a little bit not as robust, but overall, I found that I would agree with the original IARC report that there were numerous studies on all of these genotoxic effects that on a whole were consistent and robust. And for the third key characteristic 10, I also agree that the data demonstrating cell proliferation, hyperplasia, and dysplasia are robust and also found in both the inhalation and oral exposure routes.
Very good. Thanks to all the committee members for those helpful comments. At this point, we will turn to public comments on the vinyl acetate agenda item. And I will describe how this works while we look at a slide. Yep. Oh, sorry. I'm being reminded there's opportunity for the committee to say more things if they want to. So we'll look on this side first. Any other remarks? Big nothing. This side, yes.
I was-
Dr. McDonald first.
Yeah, I just wanted to ask if there was any discussion that needed to happen around the endogenous or background adducts that seem to be coming from foods and alcohol that are much higher than what you get from that are very high, and you'd have to have pretty good vinyl acetate exposure to even reach those background levels. Does anybody have an opinion or a thought whether those are relevant in this discussion?
I think I made a note somewhere that they probably were not relevant. But perhaps Dr. Felsher could add to that.
I think it's a very worthy comment to bring up and to discuss because it is often challenging and particularly confusing to explain to non-scientists why there'd be circumstances where we would not worry about the same chemical when it's endogenous versus when it's exogenous. But to my interpretation, the simple answer would be that some of these metabolites are made endogenously in a context that there hasn't been reason to believe that they would be in the same way dangerous simply because of some of the mechanisms that we've been describing that provide a way to deal with them. So we can't think of them, we have to think of them, the exposure in terms of a context. We talked about, for example, an association between exposure through nasal and gastrointestinal exposure and cancer. That's a context that would not be anticipated biologically. But I think I think you're bringing a very thoughtful and complicated issue that's worthy of the whole panel considering and discussing. Thank you for the chance to make some comments.
I think my note about that referred to epidemiologic studies primarily, and the idea would be that unless that endogenous production was associated with environmental exposure, it wouldn't affect interpretation of those epidemiologic studies. I see Dr. Eastman also wants to make a comment, and we'll turn over to him.
I guess this is the way I think of it. If I think of the dose to the individual, and this is now exogenous, now we're talking about ethanol alcohol consumption. The dose of acetaldehyde has to be so much higher to those individuals because they're drinking gram levels of alcohol as compared to very low levels of vinyl acetate by inhalation. So while there is an association between alcohol consumption and breast cancer, it tends to be relatively modest and happens with very high alcohol consumption levels. So it's hard for me to reconcile this sort of ecological study, well, the cohort study with vinyl acetate, where the doses tend to be very, very low, versus those seen with alcohol, where there's many studies. So those estimates are fairly precise. So I don't put as much stock in that one epidemiological study because of the acetaldehyde relative levels, in my opinion. Hope that made sense.
Thanks. So other
Chair,
discussion by the committee down here.
I have
Dr.
one
McDonald, yeah.
more question, sorry. One thing that I haven't heard in the discussion as it relates to the mechanism of toxicity, especially as ATSDR describes it, that, the carboxylesterase reduces it to acetaldehyde and acetic acid. And then at high doses, they suggest it is the acetic acid which is creating a highly acidic tissue, and that's what's driving proliferation. So it's almost a threshold mechanism. I don't know if that also happens with acetaldehyde, because I know acetaldehyde itself is then converted to acetic acid, but I haven't heard that discussed in terms of importance to the tumorigenicity and the plastic effects. Can anybody speak to that?
Anyone?
I believe that was the hypothesis generated by Bogdanfi and colleagues, but I don't know much more than that. That was their proposed mechanism for the effects they were seeing was due to basically increased acidity proton generation.
May I say a few words regarding acidification? Yeah, to
Yes.
us, it remains a hypothesis. As far as we know, there's no study studying vinyl acetate decreasing intracellular pH and increasing mitogenic cell proliferation. So it's a hypothesis, but it has not been validated for vinyl acetate.
Other committee discussion, members online?
I'm not sure if this is the right forum, but I know we all discussed the individual components separately, but at what point do we try to synthesize them together? Because the one thing that I don't, you can stop me if there's not the right time. We're going to have a different discussion, but I guess what I'm trying to reconcile are the animal data versus the human data, right? So we see a threshold effect in the animal data where it's only in the highest group, and then the human data, the magnitudes of risk are just astounding, and it's by increments. So I think that the question that was asked previously about what are those increments is really important. So I just want to bring that up.
Yeah, that's a really important question. So let's hold that thought until after we hear the public comments, and we'll come back to that discussion before we vote. Anything else from the committee before we move on? Nothing this way, nothing that way online. Don't see anyone coming off mute. Okay, so now it is that time for public comments. And in a moment, we're going to see a slide on how to do this. But as a reminder, if you're here in person and you wish to make an oral comment, you're asked to fill out a blue comment card. It looks like this. They're at the back of the room, and we'll call on those present to provide comments. So when you're called, please come to the microphone, giving first your name and affiliation, and then your comment. If you're joining virtually and wish to make a comment on Zoom, please use the raise the hand function that you indicate that you'd like to speak. And then when your name is called, you'll be prompted to unmute yourself and do the same. State your name and affiliation and give your comment. I'll remind you that public comments are limited to 5 minutes. I have a timer on the desk in front of me that will keep track of your time. When you get to 4 minutes, if you're still talking, I'm going to wave my hand at you so that you can wrap up. And we will terminate those comments after 5 minutes. So we'll go ahead and see if there are any additional public comment cards. I have one on my desk. Are there any more? No. Okay. So let's go ahead with the comment from Dr. Barranco.
My name is Wade Baranco, and I'm a senior toxicologist at LyondellBasell Chemical Company and serve as the chair of the Vinyl Acetate Council. The Vinyl Acetate Council has sponsored decades of research and testing on vinyl acetate, including many of the key studies addressed in the hazard identification document. All of our research is published in peer-reviewed literature journals. We appreciate that you reviewed our written comments and considered them today. We would like to reemphasize one key additional point. As stated by ATSDR, the European Chemicals Agency, and Health Canada, tumor formation in animals following vinyl acetate exposure is occurring only at high doses or exposures. Thus, vinyl acetate should be considered a threshold carcinogen, assuming CIC judges it as such. Thank you for the opportunity for providing comment today.
Thank you very much. Are there any comments on Zoom? No comments on Zoom. Is there anyone else who'd like to provide a comment from the public? Okay, hearing none. Does the committee have any questions of clarification for the public commenter, for Dr. Barranco? No? Okay. That means we move on to the committee discussion of the evidence. And what I might do, Dr. Wong, since you raised the issue, do you want to bring that up again and propose that we see if we can help you figure out where we go with this?
My comment was on reconciling the animal data with the human data, of which we only have one. So it's I mean, what the animal data clearly show, based on the nice presentation this morning, was that there is a clear threshold effect where you don't see any association or tumors until the the highest quartile of exposure, whereas the single human data that was provided, the hazard ratios are by increment, and that was at a very high magnitude of risk. So those two data don't seem to reconcile, and I just wanted to try to understand or wrap my head around, how we consider what I consider the wealth of animal study data and in vitro studies compared to the single human study.
Well, that is a very important question, and reconciling those data streams is exactly what we're about right now. I think I would add one thing that might be helpful, and that is that this is hazard identification, so we don't really have to be concerned with dose, trying to reconcile, whether this agent has a threshold or not. But let's see whether other committee members would like to jump in and try to deal with that question or raise others. Dr. Alexandrov.
So I do have one question for the committee first, and then I have a number of concerns related to them, the animal studies. But my question is about the epidemiological study. This is a recent study published this year, right? And it does report quite the strong effect sizes. But when I was reading it, and again, I'm not an epidemiologist, I wasn't sure and I heard comments that this is a very well-conducted study. But one of the things that's I found concerning is in the discussion they were talking about breast cancer and the risk of air pollution, PM 2.5, for example, and they said the evidence there is mixed. And they cited 5 studies where they had positive evidence, and another 5 or 6 studies that had negative evidence between breast cancer risk and PM 2.5. What worried me is that one study, I don't know if we're 5 years in the future, whether there won't be 3 studies that show the effect size and 3 studies that are not showing it. And I don't know when a study is too early to judge that it's conclusive, being a single study.
Good point. Any want to address that concern or Say something else, Dr. Eastman, you're looking like you want to say
I
something.
was just going to say, in the animal studies, many of those showed a positive trend. And so that the effects weren't only seen at the highest dose. Now, a number of them, effect was seen at the highest dose only, but quite a few of them, there was positive trends across doses. And I am confident when OEI looks to evaluate dose response analysis, they'll look at these issues. But as the chairman indicated, largely, dose response is a separate step in the risk assessment that happens after the hazard identification step. But I think it's relevant to look at sort of those issues related to threshold, et cetera, when OEI gets to it.
Further discussion, Dr. Alexandra?
Yeah, so I wanted to bring the concern I had about the animal study. So at first, when I read them, I said, amazing, so much supportive data. And then one thing that concerned me was seeing the things in table 8 that was shown about the non-neoplastic, pre-neoplastic lesions, which are very, very clearly increasing. And they're increasing in much higher rates than the neoplastic. You have 1 single, 2, 3, whereas you're going to have 40, 50 pre-neoplastic lesions. And what I am concerned about is, my understanding is our mandate is to use generally accepted evidence to show that this leads to invasive cancer. And my concern is that if we take that all the experiments were done correctly, then you eventually have a pathologist that's going to look at the lesion and it's going to judge that lesion, whether it's precancerous or cancerous. And we know now, because of the boom of digital pathologies, that human pathologists make mistakes. And that mistakes is not trivial. That could be, as much as 5 to 10% for some common cancers. For rare cancers that were mentioned multiple times, the disagreement between pathologists is significant. So what I got increasingly concerned is that, yes, we see a lot of cell dysplasia, you see a lot of hyperplasia. Is it possible that a lot of those invasive tumors that we are seeing are just a pathologist making a mistake in just misannotating something that's precancerous, it hasn't invaded the base membrane, to something that's cancerous? And none of those studies have had 2 pathologists or a third adjudicating pathologist, which will be, the generally accepted standards, at least when you deal with human patients. So that has been, and when I started judging the animal studies from that, is it possible there is a pathologist error, which is 10%, 10% of the pre-neoplastic get classified as neoplastic or as cancerous, then all of a sudden these things were not as conclusive. And I don't know what my fellow committee member think about it. That was my main concern about all the animal studies.
So I hear you raising a concern about the animal studies, and perhaps other committee members can help with this. Dr. Bush, I'm looking at you.
I certainly could have some comments.
Okay.
So I think these are all thoughtful comments, and certainly you have to take animal studies with the limitations of the studies. Generally, animals metabolize carcinogens more, especially alkylating agents. That's what's been reported. So generally, animals don't live as long as humans. The studies are much shorter. We know that generally duration of exposure is actually usually a much important parameter for genotoxic agents than quantity. There are issues of the difference in pathology unequivocally. But I actually think, if anything, the animal studies would underestimate effects. And the fact that so many studies show that there's a cause of cancer, if the question we're being asked is, can this cause cancer? To me, it is quite compelling. There's not 1 or 2 studies. There are multiple studies done by different investigators. The cancers have a logic to them. I agree that they can be misdiagnosed as early lesions, but actually in a 2-year study, I suspect they're missing actually neoplastic lesions, because they couldn't afford to do a whole body histological analysis to find occult cancers. And all of us would expect there to be pre-neoplastic lesions in animals that whole bodies are being exposed to a carcinogenic agent, where the cancer process will go through multiple steps. So I'd say the evidence isn't perfect, but compared to other examples I've seen, this is pretty good. This is really good evidence. There's lots of different studies. The second consideration is, I think you have to be careful using animal studies to try to estimate a hazard, a threshold, for two basic reasons. The metabolism is very different. And the second reason is the numbers are smaller. And it's very easy there is a trend here, but the reason I asked about the dosing was we really given a range to know in animals what was the expected range. They didn't of what makes sense in terms of the metabolism. But we did see some examples of a dose effect. And when you're only talking about 100 animals, I know we're not here to talk about hazard. We all look at hazard, especially when I'm wearing my MD hat, I'm thinking about hazard. But we know if we were going to talk about hazard, we're not talking about hazards we're trying to determine between 20 and 30%. An animal study with 50 mice, 100 mice isn't going to detect a 1% hazard. It's impossible. But a 1%, if we thought we were talking about something that could be a 1% hazard, that'd be a huge hazard in terms of a population. I do think that the question raised by, I believe it was Dr. Wong, in terms of the concern about the epi versus the animal studies is disjoint. I think it was you, Dr. Loomis, but it could have been several people commented that the actual hazard seen in our one epi study is high. It's a big number. It's unusual to see such a high number where there are no other studies. But I trust the colleagues reviewed this or description that there's not a reason that we found that there's a flaw in the study. It's reasonable to say other studies may not see the same amount of hazard. They try to give reasons in the study why they saw perhaps more than other people had seen. So those are my thoughts on the animal study. All important thoughts. I certainly don't disagree the pathology can't be confounded, but it could also be confounded both ways. I don't think that we can easily say there's a threshold here. I think it's thoughtful to remark that we don't see a dramatic dose response, but there's some evidence of a dose response. And I do think it's legitimate, but it doesn't change the value that there's a disjoint between the animal data and the amount of hazard we saw in this one good epidemiologic study. Thank you for the chance to share comments.
Yeah, thanks, Dr. Felsher. And let me add for the online participants, I'm trying to watch everybody in the room as well as both of you. And I may not notice your little red microphone disappearing, indicating you want to say something. So if you do want to say something and I don't notice, just speak up or wave your hand or something and I'll get to you. I think we had more comments in the room. Dr. Eastman looks like has one.
I always do. One of the points in the sort of guidance criteria that was discussed many years ago, about 20 years ago, actually, is that while essentially our charge is to identify chemical cause cancer and invasive cancer, if we see a benign tumor of the type that is known to progress to become invasive, that is counted as the same. Usually that's combined in making that determination, so that it's combination of both benign and malignant oftentimes are used in making decisions. Hope that's clear.
Okay, thanks. Further discussion, Dr. Stern.
Yeah, I just wanted to provide some additional insights or comments reflecting on the literature provided. And just to remind everyone that even though we are focusing mostly on the study by Heck et al. On the multi-ethnic cohort, because it's really the most valuable informative study because of the size and characteristics, of the other 5 studies that were all occupational cohort studies or case control studies within cohorts, 2 of them, one of them that I mentioned before, a brain cancer study that was repeated a few times, does show evidence of an association. And there's the other one that shows evidence for association for non-Hodgkin's lymphoma. So I think we shouldn't forget that with all the caveats that we already made about the way the exposure is measured. But again, in my view, such misclassification, if anything, might be reducing the estimates that we're seeing, not inflating them. The other thought that I had when I review all these materials is you know, in thinking about causal inference, we tend to think about different aspects, one of them being analogy and biological plausibility. And with all the discussion we had previously about acetaldehyde and the comments that Dr. Loomis made, I really think there's something important there to consider, given that in particular for breast cancer, alcohol is an established risk factor. There's convincing evidence that alcohol causes breast cancer, and the main mechanism is supposed to be through acetaldehyde. So if we use that logic of analogy with this compound that we've been discussing leads to the accumulation of acetaldehyde and the carcinogenicity of that, then that's something that makes me think that this is something we need to worry about. Even if, as you were talking about, this is one study, is true, but it's a well-designed cohort study, which we tend to consider our gold standard in epidemiology. So yes, it would be ideal to have multiple cohort studies so that we can see that they all find the same. We don't have that, but we have this one that we think is showing us, and I agree with Dr. Felcher, we rarely see odds ratio, hazard ratio of 5 with a dose response, which is another criteria we use for causal inference, right? We want to see a dose response. So putting all that together, I think this is concerning, and we need to take this evidence pretty seriously. I think even though it's just the one study, right, which is not ideal.
Other comments? Dr. Bush.
Yeah, thank you. And maybe this might help rectify some of the information, Dr. Wong, but, and for our newer committee members, remember that our guidance criteria, as was laid out, as per statute, the weight of the scientific evidence clearly shows that a certain chemical causes invasive cancer in humans, or that it causes invasive cancer in animals. So just reminding of that statute.
Thanks for that important information. I want to add to the discussion on causal inference. Appreciate the comments from Dr. Stern. I would also add that here we have compelling evidence of carcinogenicity in animals. I would certainly like to see more human epidemiologic evidence, but what we have is reasonably consistent in spite of the small number of studies. And then we have evidence that that this agent shares several key carcinogenic characteristics with other agents known to cause cancer. So I think another causal criterion is coherence. I think all the evidence hangs together and points in a consistent direction, suggesting that this agent also, vinyl acetate, is carcinogenic to humans. Further discussion from the committee? Yes. Dr. Landolf.
Thank you. Yeah, I'm not particularly concerned that humans are more resistant. I mean, they're more resistant to almost anything. And this is undoubtedly why throughout evolution, we've been able to grow, to roughly an 80-year lifespan. And one of the reasons, among many, for that is that the humans have a real resistance to maintaining chromosomal integrity and chromosomal stability. Whereas if you work in cell culture, those of us know that there are like orders of magnitude difference in the rate at which you get chromosomal aberrations in mice versus humans. It's extremely small in humans. You have to work extremely hard to get it. So I would expect that humans would be more resistant to many of these agents than they are. And that's not a surprise. That's a plethora of data that's grown up over the last 40 years or so, more recently. So I wouldn't get hung up on that at all.
Thank you. Further discussion, Dr. Alexander, again.
Just one last thing for me. I suppose I remain unconvinced that there is convincing evidence for invasive tumors in mice. I think that there is a high chance of pathologist mistake. But one question I wanted to ask for colleagues who work on mouse models, if there were invasive cancers, and my understanding was most of those studies did not find difference in mortality. between the controls and the exposed mice. If there are invasive cancers, wouldn't one expect to see difference in mortality?
Anyone care to answer that?
May I jump in regarding your doubt on the pathology? So I do want to mention that in the HID, we do mention that for the Bogdanski and the Lajinsky studies, independent pathology review were conducted. So they're in the table footnotes for these studies. Yeah. No comment on the mortality.
Guess you don't get an answer to that. Are there any other issues the committee would like to bring up before we vote? This way, that way, online, I don't see anything. So I'm going to propose that we move to the vote now. Unless there are any objections. Hearing and seeing none. Let's go ahead and do that. And so for the vote, we have to consider the following formal question. Has vinyl acetate been clearly shown through scientifically valid testing according to generally accepted principles to cause cancer? So I'll now call each of your names and ask you to vote yes, no, or abstain. And we'll go in alphabetical order, beginning with Dr. Alexandrov.
Yes.
Dr. Besartinio.
Well, based on totality of evidence, I would say the epidemiologic data and human studies are inadequate, particularly the study which was discussed, the latest study by Heck. There are major drawbacks in that study, which gives me pause reading their conclusion. Having said that, the animal studies, although have their limitation, as was also discussed by panel, they show consistency in results, and we see positive results in different strains of rodents, both mouse and rats, different genders. What is particularly important is the rarity of tumor incidence in the majority of those animal studies, together with in vitro data and with the CIC finding 2 out of 3, I think CIC1 and CIC10, which made a good case. I would stay with the conclusion of the IARC that was a classification as a group 2B carcinogen, but since we don't have that luxury to specify it, my vote would be yes.
Okay.
Just a quick clarification, if we can limit the responses to yes, no, or abstain, that would be great. Thank
Yeah.
you.
Thank you. Yeah. Okay. So that was a yes vote. Dr. Bush, how do you vote?
Yes.
Dr. Crespi, your vote?
Yes.
Dr. Eastman?
Yes.
Dr. Felsher?
Yes.
Dr. Landolf?
Yes.
I vote yes. Dr. McDonald?
Yes.
Dr. Stern?
Yes.
Dr. Wong?
Yes.
Very good. 6 votes are required to add a chemical to the list. And we now have a unanimous vote in favor of listing. So the chemical will be added. I don't think we need to tally them up. The agenda says we could break here for 15 minutes. So let's do that and return at 2:15. Let's try to reconvene the committee here, please. If you're all in the room, please take your seats. It is 2:15. And we're going to try to wrap up. Okay, everyone's here or nearly so, so we will take up the third item. That is the consent item, updating the California Code of Regulations, Title 27, Section 27,000, list of chemicals which have not been adequately tested as required. So we'll take that now. Committee is being asked to affirm changes in response to submissions from the U.S. EPA's Office of Pollution Prevention and Toxics, California Department of Pesticide Regulation, and EPA's Office of Pesticide Programs have indicated there are no changes. So this consideration is a ministerial duty of the committee. We rely on information provided to OEHA by the Department of Pesticide Regulation and US EPA in order to identify the chemicals that need to be added or removed from the Section 27,000 list. And so to move on to that item, I invite environmental scientist in the implementation committee, Kiana Vagethi, to give the staff presentation.
Hi, everyone. Oh, perfect. Thank you, Dr. Loomis. Proposition 65 requires the state to publish and update annually a list of chemicals that are required to be tested under state or federal law for carcinogenicity or reproductive toxicity that have not yet been adequately tested as required. This list can be found in Title 27, Section 27,000 of the California Code of Regulations, and is commonly referred to as the Section 27,000 list. It is separate and distinct from the Proposition 65 list of chemicals known to cause cancer or reproductive toxicity. The Section 27,000 list has no regulatory impact. It does not require that any testing be done. Rather, it is a source of information concerning chemicals that need further testing pursuant to state or federal law. To update the list, OEHA requests information from the California Department of Pesticide Regulation and the U.S. Environmental Protection Agency's Office of Pollution Prevention and Toxics and the Office of Pesticide Programs. OEHA staff reviewed these responses and identified one recommended change to the Section 27,000 list. Addition of 2,2,3-trifluoro3-trifluoromethyloxirane, also known as hexafluoropropylene oxide, or HFPO. Based on information received from US EPA's OPPT, further carcinogenicity, reproductive toxicity, and developmental toxicity testing are required. The letter from OPPT, along with additional background, response letters from DPR and OPP, and a mock-up of the proposed changes are available in the staff report provided to the committee and posted online on November 27th. The proposed change is also shown on the slide. As Dr. Loomis mentioned, this is a consent item and a ministerial duty of the committee in that the DART-IC and CIC committees use the information provided by DPR and US EPA to identify the chemicals that need to be added to or removed from the Section 27,000 list. We ask the committee members to vote in favor of the proposed change so OEHA can update the list. And I'll turn it back over to Dr. Loomis, and we're happy to take any questions. Thank you.
Are there any questions of clarifications from the committee? Remind you that this is a consent item, so we don't need discussion, but for information, is there anything? Nothing that way, nothing that way, online, nothing. Since there are no questions, we'll turn to the vote. Question before us is, should Section 27,000 of the Title 27 of the California Code of Regulation be amended as indicated in the staff report? Now call your names and ask you to vote yes or no. Again, as with the vote on listing, this is simply yes, no, or abstain vote without justification or explanation of why you're voting as you are. Dr. Alexandro,
Yes.
Dr. Bessartinia,
Yes.
Dr. Bush,
Yes.
Dr. Crespi,
Yes.
Dr. Eastman,
Yes.
Dr. Felcher,
Yes.
Dr. Landau.
Yes.
I vote yes. Dr. McDonald,
Yes.
Dr. Stern,
Yes.
Dr. Wong.
Yes.
Very good. Unanimous again. The change is affirmed. So the next item is staff updates. That will provide current information on Proposition 65 listings, regulations, and litigation that have taken place since the last meeting. Again, Kiana will present those listings and safe harbor levels.
Hi again. Thank you, Dr. Loomis. I'll be providing you with an update on important Proposition 65 developments since the last CIC committee meeting. I'll start by going over the chemicals or endpoints to be listed or under consideration for potential listing. Then I'll review the proposed safe harbor levels. After that, I'll turn it over to our counsel, Corey Friedman, to provide a brief update on other regulatory actions. Last week, the Developmental and Reproductive Identification Committee considered listing BPS for male reproductive toxicity. The DART-IC unanimously voted yes on the question, has bisphenol S been clearly shown through scientifically valid testing according to generally accepted principles to cause reproductive toxicity based on male reproductive toxicity? And so the male reproductive endpoint will be added to the listing of this chemical. In December of last year, BPS was added to the Proposition 65 list for reproductive toxicity based on the female reproductive endpoint. BPS remains under consideration for listing as causing developmental reproductive toxicity. Information from the BPS data call-in will be used in preparation of a hazard identification document for a future DART-IC meeting on this endpoint. And recently, OEHA issued a data call-in on N-methyl N-formylhydrazine to solicit information related to its carcinogenicity. The comment period ends January 10th, 2025. Since the committee's last meeting, we proposed to adopt a no significant risk level for exposure to titanium dioxide, airborne unbound particles of respirable size, where both of the following intake levels must be met. 440 micrograms per day for airborne unbound titanium dioxide particles with diameters of 10 micrometers or less, and 44 micrograms per day for airborne unbound titanium dioxide particles with diameters of 0.8 micrometers or less. We're still in the regulatory process for this proposal. And now I will turn things over to Corey.
First of all, thank you all for your patience with the construction sound effects earlier. Hopefully that won't interrupt this, but if it does, thank you all. Okay, so first in October, we have finalized regulations to provide an additional safe harbor warning option for businesses that cause significant exposure to acrylamide from foods. Second, in February, at your last meeting, we told you about a proposed rulemaking that amended existing regulations and added some new sections to the safe harbor warning regulations. This proposal has been finalized and approved. It amends the sections visible on that slide there. And that takes effect on January 1, although there is a 3-year implementation period before it's fully effective. These regulations make the short form warning more informative to consumers by requiring at least one chemical name in a short form warning. So to give an example, instead of just saying warning cancer, the short form warning would say something like, warning can expose you to formaldehyde, a carcinogen, and then the website where people can learn more. The regulations also provide additional warning content options for businesses to select from, and provides businesses that currently rely on the existing short form warnings 3 years during that phase-in period to transition to the new safe harbor warning content for short forms. The regulations make explicit that short form warnings may be used to provide safe harbor warnings for food products, provide a 60-day transition period during that 3-year implementation period for retailers, to give them 60 days to update online short form warnings when they get notice from a manufacturer that the new short form is, they've updated to the new short form warning. This regulation package also provides new tailored safe harbor warnings for passenger or off-highway motor vehicle parts and recreational marine vessel parts. So I'm next going to talk about some of the significant litigation. So I mentioned the safe harbor warning for acrylamide in food. That is relevant to ongoing litigation, which existing members who are not new to this meeting heard about previously. California Chamber of Commerce versus Bonta involves a First Amendment challenge. For the new members, in recent years, there have been several challenges to the Prop 65 safe harbor warning content. The general argument is that they violate businesses' First Amendment rights. This case, Chamber of Commerce, is currently proceeding. There is a preliminary injunction in place which prevents enforcement of the warning requirement for acrylamide in food. This Chamber of Commerce has filed a summary judgment motion, which, if successful, would result in a permanent injunction, and the hearing for that motion is scheduled for January 23rd. So the next time this committee meets, we may have a result on that, or at least on the summary judgment motion. If the summary judgment motion is not successful, the case continues to trial. In Personal Care Products Council versus Bonta, this concerns titanium dioxide airborne unbound particles of respirable size. In that, the Personal Care Products Council filed a First Amendment challenge to warnings for that listed chemical for cosmetic and personal care products. In that case, also a temporary injunction is in place and a summary judgment has been filed, but there's no hearing date for that motion, so the court could rule at any time. And then in Physicians Committee for Responsible Medicine versus Newsom, a challenge is pending to the decision not to list processed meats as a carcinogen. Processed meats was the subject of an IARC monograph, but OEA has not listed it. And that case is still pending in Sacramento Superior Court, but I don't have any significant developments to report. We do not have a hearing date in that matter. Just to let you know, outside of the Proposition 65 context, businesses are challenging government mandated disclosures in other contexts. So it is possible that that decisions that are not about Prop 65 in particular could have an effect on California's ability to require Proposition 65 warnings, particularly in consumer products. Does anyone have any questions about those updates?
Can you tell me, say again, what you just said about the last point of possible pre-exemption or exemption? What was your last point you made?
Oh, just that First Amendment questions and the extent to which government entities can require business disclosures that issue is being litigated in context outside of Proposition 65. And so it's possible that a decision could be issued in a non-Proposition 65 case that would also have an effect on the ability of California to mandate Proposition 65 warnings for listed chemicals.
Thank you.
So where is that litigation in the federal court system now?
Well, the two cases that I mentioned are currently at the trial level. There have been in the past appellate decisions that have been reported to this committee, but those two cases are at the trial level.
So which court are they in?
Oh, which district?
District.
I can get you that information, but I'm afraid I don't remember
That's
off the top
okay.
of my head.
You know, the districts are different, right? And so
Yes.
it comes from the 5th district might be an interpretation that's highly consequential, for example.
Yeah, I mean, we'll see what happens. Also, it's possible they could go back up to the 9th Circuit again, but we don't know that at this point. And as you can see from their case names, OEHA is not a party to those cases. It is the Attorney General's office that is litigating them. We are a party in the process meet case. Any other questions? Okay, then that is the end of my presentation. So Chair Loomis, if you would like to continue.
Thanks to both of you. At this point, I'll ask Acting Director Edwards to summarize the committee actions today.
Great. Thanks, Dana. All right, so today the committee considered and deliberated at length on whether to add vinyl acetate to the Proposition 65 list as a carcinogen. By a unanimous vote, the committee approved to list vinyl acetate. The committee also voted on a consent item to add 2,2,3-trifluoro, 3-trifluoromethyloxirane, also known as hexafluoropropylene oxide or HFPO, to Section 27,000 list that's published in the California Code of Regulations. The vote here was also unanimous, and so the chemical will be added to that list. I want to give thanks and acknowledgement for the work that the committee did to prepare for this meeting. We really appreciate your effort and preparation. And of course, I want to add my thanks to the staff for all of their work to put that document together, and also to the audience and commenters today. We do have one final item, and that is that Dr. Thomas McDonald has informed us of his intention to resign from the CIC committee after his 7 years of service on this committee. So this is Dr. McDonald's last meeting. It's a tremendous service to the people of California. So I would like to allow some time for the committee members and OEHA staff to express their thanks to Dr. McDonald and wish him well.
Yeah, thank you very much. Yeah, I am retiring in January, and I'm going to try to make it a clean break with work as well as other toxicology.
That's hard to do, I can
Yeah,
tell you.
yeah. Many of you may not know that I started my career at OEHA in 1994. Was there for 11 years, and I really enjoyed my time there, especially working with very impressive scientists. I had to smile and chuckle a little bit when you were talking about acrylamide in food litigation, because I think I did the first NSRL on acrylamide. Anyway, I've been, enjoyed the last 7 years on the committee, and I appreciate to serve.
Thank you. I will now turn it back to Dr. Loomis to adjourn the meeting.
Well, thanks, Dave. I'd like to echo the appreciation for all the hard work of the staff producing an excellent and really clear and concise hazard identification document. Really, really helpful for our discussions. Thanks to the members of the public who joined and gave comments, and especially to the committee, new members, continuing members, and retiring members. Really appreciate all your work on this. I now declare this meeting adjourned. Thank you very much.